Okay, so in my last video, whoops, that was unexpected. Let me silence my phone. Okay. So in the last video, I worked on the platform cleanup stuff, and that's what I'm going to be doing this time too. So I don't actually need this up. I did find, here's like the Intel architecture. I started reading it, so we can talk about that if anyone else is reading up on Intel 64 architecture. Right now I actually just read the history of the processor, basically the order in which they added features, which is pretty interesting in its own right, but not necessarily the most useful for knowing the architecture details that I wanted, but it's a good place to start, I'm sure. And now, the system functions problem. So last time we were able to get this down to 5 from 9 threading functions. Since then I've been looking at things, and it's gotten harder for me to find ways to remove stuff. Like, this function's not in use anywhere now, but if I'm ever going to do any profiling, it has to be available. So that one can't go in. And in general, timing things have to be functions. That's what we talked about with post job, cancel job, grow thread memory, acquire lock, release lock. So that doesn't actually need to exist, we said. There's an argument to be made that we could get rid of that, but that's like one function that I know I could definitely get rid of if I wanted to. I'm more interested in figuring out details of these things. So I'm going to talk to you guys about what I've been thinking about doing with these, because there's a few routes this might go. First of all, how many functions do we have? We have 5, 6. This is actually like all about files, so I'm going to just group these together. So here we have files. How many of these are there? 1, 2, 3, 4, 5, 6, 7, 8. And I'm counting these because, remember, my goal is to optimize for eliminating functions to some extent. Like, that's one of the things I'm putting a high priority on. Here's memory, for which there are 2 things. This is clipboard, for which I have 1 thing. Here's time, which I have 1 of. Here's CLI, which I have 4 of. Threads, which I have 5 of. And debug, which I have 3 of. So, if I can get these numbers down, that will make me happy. That's kind of the point. And looking at the file stuff, one thing that I know is tricky is some of these I can't really do anything about. Like timestamp now is another timing situation, right? So the difference between timestamp now and time is that this encodes it in terms of a timestamp. Like if you saved a file right now, what timestamp would it have? And that's like encoded in a different way, and so I just wanted to have that separately, but that could be a mistake. Maybe what I want to do is have a way of converting system times and timestamp times to the same time system, because then I could get this all the way down to like 7 functions, right? Because then this time function would be the same as this. So that might be an interesting route to look into. Frankie4Chess asks, why do you want to minimize number of functions? Wouldn't that just make less, more complex functions? So he's saying basically the idea is that if I have this many functions now, if I try to eliminate them, I'm just going to end up having fewer functions, but each one is going to be more complex, whereas a bunch of small functions may be simpler. Maybe I should be. I got an email, so I'm going back to hopping around to random stuff in the middle of my stream, which happens a lot. Fucon says I'm on creative, and I got an email about that. They might have put me on creative when I got that email. Let's see if I can put it back on programming. Okay. Okay, should be on programming again. Anyways, talking about this number of functions thing. a lot of the times the truth is that if I have fewer functions, um, the complexity like per function does go up, or it stays the same. Like it doesn't go down certainly, but uh, there's a certain situation where like things work out nicer. Like you actually reduce complexity by finding a better system. Because in general, just like the real issue becomes, and they talked about this a lot when you talk about complexity. What actually makes something complex, I'll draw a quick diagram of it, is when you have um, two different layers, and remember your layers are made up of a bunch of points, like different. That's not a great way to draw a box. So if you have a layer here, and a layer here, right? And each of your layers is made up of a bunch of different nodes, where like a node is like a certain point in the code, not necessarily a function, but just like even points within functions, spots where things happen. You have points in the code, and so those points can connect to each other, right? And the point is, the more connections you have, like the more things you have that allow these layers to connect, the more dependent they are, right? So even if having this many connections means this is very simple, right? This is simple, and this is simple. But then the problem is that you've put the complexity here, complex, in the interface. And that's almost never what you want, because that's dependencies, right? If you take the complexity in the code, you can always just fix the code itself, and if you have fewer connections, right? If you just get this down to like, oh, they can connect in this way, and this way, and have the same number of things, maybe this end becomes complex, right? In exchange for that, and this end still gets to be simple. But now the more important thing is that the number of connections gets to be simple, and that gives you flexibility. That's where you get the freedom to do more stuff. So I care about that, and then whether I move complexity up or down, I don't actually care too much. I'll probably try to spread it evenly in both directions in exchange for simpleness. Garlando Bloom asks, Mr. Fourth Dimension, did you ever give your thoughts on HMCon? I didn't really give a full recap, if that's what you mean. Do you want me to write up a blog post? Because I was thinking about doing that, or I could recap it now. It wouldn't be very coherent probably if I just came up with it right now, but I haven't done like a blog post, which is something I want to do when I get like to the weekend here. Alright, anyway, what I want to do is first pursue this idea about time, because it's kind of weird to have two different time systems, and it should be possible to convert to a single time system on the platform side. So that will just give me a function less, just for getting that figured out. So let's look into what makes those different. There's system time, and that's using query performance counter, and it does all that work. Now, what does a timestamp now look like? Timestamp now is get system time, and that's system time struct. I might just say that there's no such thing as this, and that let's see, how does this work? High date time, low date time. Now, what I don't know for sure is if this, like, this might make, I think right now the timestamp now doesn't actually care about like content continuousness is the thing, right? Like it might have parts where it leaps forward, and for this one I care about actually measuring microseconds correctly, whereas in this one I just care about order of events. So obviously if I have a thing that does microseconds continuously, and it works with the stamp thing, because when you read a file stamp, you don't get to use the system, right? If I could ask the file stamp to give me a time, like to get a time in relation to query performance counter, it'd be fine, but you can't get that. So I need to use just this system and make sure that it does continuous. It does like a continuous run of milliseconds. Okay, so before I get to that, Garlando Bloom wants some general thoughts on Handmade Con, and I'm happy to oblige, so I'll give that a few minutes of attention. So, I could review the whole experience. I mean, my experience was largely similar to Garlando's experience. If you are familiar with his blog, you could read that. In terms of, it wasn't my first time flying, but, I got there, and Seattle's a really interesting place. I think I could imagine living there because I'm not too worried about the weather, and that's like the only downside, because obviously the food was great, and I really liked sort of the architecture, like the way the city was built in a lot of ways I liked, and the people were pretty cool. Although that might have just been because I was hanging out with handmade con people the whole time. That might have created the illusion of cooler people, but like it seemed like people were cool. And yeah, so the actual convention itself is the only thing I'm super interested in telling you about. And I thought there were some like really interesting themes. Like, if you sort of look at a lot of the things people said were response. Like Mike Acton started the tradition right off the bat when on his of responding to things from previous talks, and to a small extent that continued in everyone's talk after that. Although he did the most response stuff to Tommy, there was still like a continuation of certain ideas, and the really interesting themes were the idea of like lock-in versus flexibility. And Jonathan Blow talked about like if you were able to decipher some of the things that we're talking about were at one point he was talking about flexibility of code and how a really nice program is just a bunch of nodes that pass information one to the next, and that the real programs involve more interconnection than that, and that's what makes them hard to make. And that reminded me actually of what Mike Acton had been talking about of lock-in, and what Tommy had been talking about of lock-in, right? So that was an interesting theme of like they were talking about you've got these variables and things and stuff that will lock you into in certain ways, whereas John was sort of talking about the flip side of that, where it's like ideally you don't have that, because if you don't have that you have 100% freedom, and in reality you have this web. And so the first two guys I mentioned, Tommy and Mike, they were saying like you got to know which things are going to lock you in and plan around those, whereas John's approach was a little bit different to the same problem, which was try to find ways to not get locked in by that. Find a way, like maybe movement speed is a really great example where you just can't avoid it. But his sort of talk sounded like on your first pass, do as little as you can to actually create lock-in situations. And I think a lot of the convention was actually like that, where there was like clearly a few themes that came up in several ways. Another great one that I think about that I don't think was super obvious was Tommy right at the beginning said he thinks you should make a tool so that it makes it as easy as possible for your artist to give you the best work they can do, right? Something like this, like if you want to get good work, make it so that the easiest thing you can do with the tool is to make good work. And at the very end, the last talk was about with Ron. There's sort of like a thing there where it's like it sounds like an odd thing that he does to make adventure games. He makes this scripting language, and like on the Commodore 64, it took up more than half of the memory just to run the interpreter. Just like the memory of the interpreter itself was bigger than the rest of the game. And even now, with higher level languages, he's still making his own language. And that reminds me actually of the same thing, where I think that in reality the most important reason for him, from like if I was able to like dissect it and figure out why I think that he prefers that, it's probably a similar thing to what Tommy was saying, that it's not necessarily going to lead to better code or even faster, but it's the best. It allows him to work in the way that's best for him. Like it's the thing that makes it easiest for him to make the best thing he can do, right? And maybe most people would look at that and go, I don't want to make this game this way, but that doesn't matter in his context of the way he works, right? And that's another thing. Working in context was super awesome. But in general, that's sort of my thought, is there's all these different themes. And so if I were to approach looking at the conference, I wouldn't even go speaker by speaker. I would pick out these themes that I thought were interesting and then look at them, because there were a few big ones that seemed really important to me that sort of carry across the whole conference. So that's some of my thoughts, topics I thought were particularly interesting. Okay, so that was 5 minutes. That's kind of what I was going for. Let me get back to this timestamp thing. So, my question that I want to look into is, here's sysnow. I translate that into a file time. Up here I've got a file time. So the question is, given a file time, can I get continuous microsecond precision or not? If I can, then we're golden. So we need like file time. Time that is easy to display to a user, use file time to system time function. It is not recommended that you add and subtract values from the file time structure to obtain relative times. Instead, you should copy the low and high order parts of the time to a U-large integer structure. Perform 64-bit arithmetic on the quad part member. Copy the low part and high part members into the file time structure. Okay. Do not cast the pointer to a file time structure to either a U-large int star or int 64, sorry, because it can also cause alignment faults on 64-bit Windows. Okay, not all file systems can record creation and last access time, and not all file systems record them in the same manner. For example, on NTFAC has a resolution of 10 milliseconds. Write time has a resolution of 2 seconds, and access time has a resolution of 1 day. Okay. NTF access time has a resolution of 1 hour. Okay. Values outside of 0, positive -2. What about that other struct? How does that one work? System time. Because maybe I can convert files time to system time, and maybe system time will be closer to a continuous thing. That sounded like I could maybe get what I wanted, but there's a little bit of, ooh, yeah, this is not what I want, right? Because this is where things get complicated when they're all broken out this way. Okay, not system time. Not system time. Okay. So that's 64 bits. Low date time, high date time, sure. It looks like I can pack this into a U-large integer and then do if I remember this correctly, this is just going to be yeah, okay. So what I'm going to do is say, it looks like file times can be converted to U64 like that. And then the question is, after I do this, do I get microsecond precision on that? Get system time to file time. Let's take a look at that function. System time to file time. Does it work on a microsecond basis, or what's the deal? it doesn't say. Let's take a look at this. Get system time. Structure receive not be return remarks. What's the resolution of this function is what I need to know. Set system time. Retrieves the current system date and time. The system time is expressed in coordinated universal time. Retrieve the current system date and time. In local time, use get local time. Sure. So that means that the user's clock won't matter, which is nice. What's the resolution? Okay. Ah, okay, let's try this function. Get system time as file time seems pretty nifty. That might be what I actually want in here, because then I can just get rid of sysnow, and it would just be get system time as file time. File now. Huh. So I have an idea. Looks like I have to do something a little more clever than just switch to using this, but we'll at least get rid of this function. And we'll say anywhere where we used that, timestamp now will just not exist, right? Systime, right? Get file timestamp, right? And then whenever I ask for the system time, what I want to do is get all of that, and then I want to take, once I've got that start p count, quad part minus start p count. What is start p count? Where does that get set? Okay, cool. And then I want to do result plus equals, and it's like the win32 vars start time, right? And then I'll switch these to U64 to U64, and now start p count, start time, and start p count down here is getting set, and I want to do at that very moment, I also want to do file time, get system time as file time, and then win32 var start time equals file time dot, and this is the high part of the file time. So let me look at file time again. What's the name of this stuff? Now, I'm not actually sure that this is a good idea. There are reasons to believe that it might not be. The main one being, like I said before, the actual timestamps need to sync up with my timing system. Right, that's the main thing. So the problem could be that for some reason they don't add together, but I don't know why that would be, because I'm measuring those in microseconds. This is being measured in microseconds as well. Right, I'm actually not sure about that. Is load date time measured in microseconds? Well, I mean, is the whole thing measured in microseconds? I can't find this info. It's not, like, around for some reason. Right, yeah, you can get rid of those. Okay. File time structure into a time that is easy to right. Do not cast. Okay, not all volume systems can record creation of writes. Create as a resolution of 10 microseconds. What is the resolution? A function structure can allow for values outside of 0 or positive values typically specified by DW load date time and DW high date time members. For example, the set file time function uses that a file's previous access time should be preserved for. Okay, for an example, changing a file time to the current time. That's right time. Bit value representing the number of 100 nanosecond intervals. Okay. So that's like annoying, but okay. I'll deal with that. Fair enough. If they want to give me more resolution, why can't they just have a unified time system with one resolution that does everything? Like, there might be a good reason, but why? What is going on? Anyway. So, the file times here are measured such that they look 10 times bigger than what they actually want to be. Right, so if I take all of that and then I divide this variable by 10, I get it where it needs to be. Then the other trick is whenever I get a file's timestamp, I have to take the result and divide that by 10 because it too needs to, like, the result of this needs to be in sync. And honestly, I don't really like this timestamp struct. That's kind of stupid. So we're going to try to make that happen without being stupid. So result success last write equals data dot ft last write time. Fair enough. Now it's just system time. 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 Timestamp. Okay. So let's see where we are. It's kind of weird. I mean, it should have opened the tokens within that time. So there's some kind of problem where the tokens aren't opening. Okay, let's look into that. That might not even be new. That might have been the result of work I did yesterday that I didn't notice. Alright, so the question is, if I come over here and I look at the parallel job, at the end of that job, it's supposed to say, boom, right? Does it ever reach that point, first of all? Okay, does it launch the job? No. Okay. What would that be? Would it be that? Would it really be that? Okay, let me see. Okay. Okay, if I get to the end here, and I enter the open hook, okay. So it's determined to treat this as code, and Lex as CPP is the first thing. So it pushes that parameter. You can see there it's doing all the parameter pushing stuff that it is in the API, and then it executes this command for doing settings. And now the function itself starts set settings, and the first thing in the parameter stack is Lex as CPP file. So do tokens exist? No. So, and v equals 1, yes, that's the value. So then it does first Lex parallel. Okay, we get in there. If file still Lexing. Oh, that's wrong. So 1726. Got it. And what file? File view. Alright. Still not great. Did I not recompile? What the hell? Stop, stop, stop. Recompile. There we go. Okay. So what's next? Back to the system stuff. It looked like the timestamp thing was maybe working, but of course I didn't actually test it. We just didn't crash. So let's give it a proper test by opening up something like this. I can kill this now, so it'll run through, and that's a text file, so it won't try to lex it. So that's good. And now I want to see. I'm gonna kill this panel for now. If I edit this outside of 4coder, if it notices. So that's the whole point of the file timestamp. Save. Bop. Alright, it seems to notice that we're behind the OS. If I Control Shift O, we get the new one. I think it works. I believe that that works. So, let's shut all that down. Okay, so that's one thing out of the system layer. Timestamp now appears to be gone. System file. So now this is down to 7. So that's a nice one. Now, file timestamp. Definitely need that one. So a file list is used for iterating over lists, and I like that system because if I were to do it the other way around, which is to like expose the iteration API, it'd be more functions. But man, it's tough, right? Because if I have right now the way a load file works is like you ask to load a file, and then you get that file back and you just use it until you're done, and then you free the file, and when you want to save a file, it's really hard to imagine these systems working any other way. The only thing I can imagine is like a thing where you say, oh, I want to open a file, and then you like you say, I want to open a file, and you write to a buffer like a message that says, I want to open this file, and then the platform layer like begins opening it, and somehow you have to bind like I want to open this file, and you give it an ID or something, and then on future frames you can query like give me all the information about this one file, and the platform layer then can say, oh, it's got this timestamp right now, it's got you'd still have to have like a load function in there, wouldn't you? Like you'd still have to say what's the current state of it, and you might want to reload that. You'd still have to free the things you load. The only thing you might do is say that there's a such thing as you get the size of a file, and then you read it. You could get rid of load and free is what I'm thinking. So you'd say what's the size of this file, and then using that information you would say here's a pointer, fill it up with the data for that file. Tough. This is where I'm wondering like if I don't want to go to a crazy extent. It seems like a bit overkill to totally like try to get this down to no functions would be overkill. But you could definitely imagine a thing where like I tried to do it all as a data protocol. It's just like I did with the force redraw. It's just gonna get a little harder because like you got to do synchronization stuff, and you got to like have an ID that matches it somehow. I'm trying to imagine what that looks like because I still have a fixed number of files, right? That wouldn't have to change necessarily or at all. And really, it's not even about the system file so much. It kind of is because of the file timestamp. But really what I'm doing is I'm just trying to get the data once, right? And use it, and then I throw it away. And it might be nice to say that I don't have this extra copy at least, because I could definitely eliminate the extra copy that I'm doing now if I went with trying to eliminate this free file idea. And instead you get the file size. Get memory, free memory. I wonder how much get memory is being used in the application side. Okay, so it's being used for a style library export. And I wonder why that is. Get some memory. What does it do with this? It frees it right at the end, so that should be unnecessary. I could eliminate that. System get memory style, so pass the transit memory in here. Again, this looks like it says that what I want to be doing is not actually allocating and freeing, because that's what happens here is I allocate styles, and then I free styles, I free the memory, but that could all just be done through the spare memory if I worked on it, and this one. Yeah, I think I'm gonna try to eliminate get memory and free memory. That seems like a good idea. When did I start? 4:30. I'm an hour in. All right, so we've got another hour. Let's try to get rid of get memory and free memory. Or we're just gonna say you never get to ask the platform. The application never asks the platform for additional memory, at least not with a function call like that. In the future, I might say, like, I want to grow the memory, and when I want to grow the memory, what I do is I say, like, I have an output number where I say, hey, please grow me to this size now, and then it can do that. Or maybe a thing that just says provide a new chunk for me to build a new, like, to expand my general memory allocator into, right, something like this. So there's some options there, but I think I want to try to get rid of the get memory stuff. I'm just curious, what about the free memory stuff? What if I take this one out? Should be 3. Oh, yeah, 3 there and 1. Okay, so that's what I'm going to do. I'm going to push this down to 0. And instead we'll do these the way they should have been done. So this right here doesn't, let's see, what else does it use system for, if anything? Save file. Okay, so we still need system, but I also want my memory options to come in here, because that memory stuff is more sophisticated now. And instead of this, what I need is mem part mem options. Yep, so part, what was it? Size, okay. And I need to do like a temp memory there. Alright. Now, what about this one? The system pointer came from where? From where did it come? Step draw library. Well, I want my memory options now. And then, instead of all this, I want to push an array from mempart with that type and this much. Okay. And then instead of freeing that, we'll end the temp memory down here, which reminds me I gotta begin the temp memory. Right there. Okay. So neither of these frees needs to be there. The end temp memory will carry all of that. And then the only other one is this one, which goes kind of similarly. Mempart char. I think this needn't be star actually. I think it only need to be star. String.size plus 5. Who knows, but I'm gonna trust it. It's probably for 1, 2, 3, 4, 5. Yeah. Okay, makes sense. Okay, so that right there is annoying. I'll just call that data. How about? Unless I already have another data floating around somewhere. Nope. Alright, so I ended up with two different things called mem, but that's fixed now. Alright, so this needs to have the memory options passed in. Step draw library. And I'm gonna go ahead and bet that this doesn't actually have a pointer to mem. Let's see. View. No, it's under layout. Ah, the view does have memory options. So, there we go. Awesome. System get memory. Wherever I define that, I want to redefine this now to be private. Cool, and then I'm going to make this one private. 32 free memory. Why is there to do right there? What haven't I done? Why didn't I finish the to do? I think that's not real. I think that was probably when I was doing the change around, and no, I don't need it. Like, whenever I write this without explaining, it's because it's like I mean to do this thing next, and it's just a reminder. And this looks completed, and it's like been completed for a while, so that must be new, is my reasoning. So, hello, insofar as, by the way. Alright, let's go back to the system header and see what else we can do. So, memory is just gone. System get memory. System get memory, free memory, it's all gone. We've completely eradicated the use of system memory from the application side, which is awesome. Except for in those times when it uses system memory to do this thing and this thing. And does it use system memory for anything else? And this thing here, but that one probably... I'm not sure. Something that occurs to me a lot is that it might be much easier to reason about threads if they were more like mini applications where there was a loop that they had like a step function and an init function, and they did their init function when they launched, and then they stepped, and after every step they did, like, it went back to the platform so that they had to chunk themselves up into steps. But then there are always like processes, and it's like I just want to write them as one-off functions, and it's very difficult to, like, I don't want to overcomplicate the application writer side that much. But if I were to make that call, that you had to, like, treat your thread as one step of a loop instead of a one call through function. So, Fucon, I mentioned my new vision a little bit. The idea that I had was that you would do this all as a data protocol that's sort of more like handles, and you would sort of issue the fact that you wanted to load a file, but then you would wait until the platform, like, filled that data in saying that there was a file, and you'd have to somehow use IDs to sync up between the application side and the platform side which file you requested to which file it provided, right? If I request a file, I need some way to know when it comes back if it doesn't come back right away. Because the nice thing about this is the way I know which file I want is it comes back right away. Whereas if I, like, request something and then I sit around and wait, like, if I imagine like that's something that's gonna be streamed in, and once it's ready I can use it, then I need a way to link to that. Like, I need an identifier or something that lets me look that up. And I wasn't sure how I would do that, but that's sort of an idea I had to, instead of structuring the program where I have the ability to just ask for a file in an instant, I would ask for this file to be streamed in, uh, uh, and yeah, that's all I can really do to describe the sort of change I'm sort of thinking about making. Because it doesn't. There's certain things about it that make a lot of sense, and there's certain things about it that seem like a totally bad idea. Like the reason it's a totally bad idea is that it's a lot of stuff that I'd have to change. Like it would change the structure of the application side and the platform side, and it adds complexity to a large extent on both sides. Like that is a trade-off I'm not sure I'm willing to make, and I'm not even sure how much simpler the interface between these things is. Like it's a data interface, so in a way you could get it all the way down to 0 functions, but then you got to deal with threads, or you have to wait a frame every time you request something, which you'd probably have to wait a frame on the request anyway. There's just a lot of ways where it's not necessarily great. Alan, quick question. I was thinking about basic text editor architecture and thought of a file text buffer for input that is being looked up and rendered on screen as it changes, as I scroll through, save to file, update file, and control S and stuff. I mean, yeah, that's kind of a description of what a text editor is. I'm not sure what you mean by, like, what the exact detail you're asking about is. That's kind of how it works. Okay, because it's just the only reason I like that is it seems like that has to be the correct answer, the streaming files in, because if I stream in a large file, by the way, I said I would spend some time getting rid of memory, and it happened in like 10 minutes, like just like that. But anyway, um, if I change up how this works, especially all of these functions, right? These four, which are about interfacing with a single file at a time. Uh, the advantages are like right now when I load a large file, I get a spike on the frame because if it's 10 megabytes, it's got to page all that in. It does a couple of copies to get it in the right spot. Uh, and well, uh, there's like no other way to solve that. Like the main problem that I see is that if I on the application side, if I don't make changes, then like I'm always going to rely on the fact that it loads right away. So what I think I want to do is start moving towards a world where I'll keep this interface, but I want to move towards a world where I request loads and then I don't use them until the next frame, and I link them by ID, because it seems like someday I have to go to that place. And once I'm there, I can do a lot of this as a data protocol instead of as a function interface. So yeah, it's time to find places where I'm using load file and see if I can do anything about doing loads differently altogether. So style library import, for example. See, this is where it's tough because it's gonna want that memory right away, and the whole thing is written as if it's got it right away, but it's gonna have to change. So what I'll do is I'll start by rewriting this one just to figure out how to make it work. I'll put this back in for now. And then if I come over here to style, so what I actually want is I want a situation where I'll keep this, and then what do I use system for? Nope, just those two things. Okay, great. So it'll be like, here's the file. What do I use the file name for? Okay, won't need the file name. And then I need the rest of these. Insofar as asks, have you thought about memory mapping files? Yeah, I mean, I haven't thought about it too much. It doesn't really fix the problem. I can't... If I understand memory mapping correctly, which I may not, I would still have to do an extra copy because I don't... The trick is, like, I process the file after I bring it in. Like, here's the thing I don't know about memory mapping files is when you memory map a file, as I understand it, it kind of just is doing an allocate and putting the text of the file into that allocation at the same time, and it does some trick to make that faster than usual file opening. But there's a drawback to that, right? And that's that you edits, like, that it tries to sync up edits in that file space to the file, right? I might be totally wrong there, but I always thought there was something where, like, you can't just treat the memory afterwards as memory that you would treat. Like, you can't say, here's a pointer, it's this large, the buffer is this large, fill it up with a file and do a memory mapping that way, right? Like, because I have, like, a spot in memory where I want the file to go. Say, right, I've got the pointer, right? I got the pointer to a spot I want, and I have the right amount of memory there. I memory map that in to that position and then just treat it as memory. I can look at memory mapping. It might be the way to go. It's not really relevant now because, I mean, if it's possible, it'll be possible both ways. And it seems like at 10 megabytes, you can't just say you'll memory map a file and then expect that it's... Unless the way they do that is, like, they only... Maybe a memory map file means until you read a spot for the first time. Like, if I have a 10 megabytes, you could imagine a thing where that's a bunch of virtual pages, and only when you index into that virtual page for the first time does it notice that there's a bit and it says, oh, this needs to be loaded, and then it goes to the disk and gets the correct value for that memory. And until you read from that spot and it doesn't load it, then you can, like, open files instantly, and it's as if the memory there had the value of the file. If that's how memory mapping works, that's awesome. If not, I don't see how it matters. But I'd have to look into what memory mapping does on Windows. What I just described should exist. Like, if it doesn't exist, I'd be very upset about that, because that's an awesome idea I just described just now. Like, that's how things should actually be set up, as far as I'm concerned. Okay. Library import. This needs to do everything that this would do. Early exit. Except for freeing the file. And yes, that should all be exactly the same. Result starts where? Well, I guess going back to that idea I had earlier, a couple minutes ago, a minute ago or something, there maybe is just not that many cases where you memory map in a file or you load in a file and don't look at everything, because like most of my things will end up looking at the entire file pretty quickly after it's been loaded. So I'm not sure how much of a win there is to be had for what I described, but certainly in some cases that would be a win. But I'm not sure how common those cases might actually be. I'm not sure if it would be a win in my case. Like, I'm not convinced that it's not, but I'm not convinced that it is. But I don't see any reason why it would be at the moment. Okay, so that is good. This hasn't been used in a while, so it's possible that it broke. It's also possible that I didn't build somehow. So let's take a look at that. Plus the style system is way screwed up. I did not know what I was doing when I first started, and I have to come up with I have to just convert Matthew Van de Vander's mono-chi format forward, and then I can abandon my old format, but I haven't done that yet. That's no good. Format for use. Okay, why is the call stack cutting short there? That doesn't make really any sense. Call stack must have been screwed up by the breakpoint that I triggered. Okay, so here it is trying to import, Here it is, doing the import without relying on system load file functions. And let's see. Okay. Char 24, font name size. Font name size 4. Mem copy. Name. Font name size. So, named name. 4coder. Name size to name size. Font name size. Hack. Okay. Seems fine. So this step through is doing just fine. Okay, so it converts all that in. All of those conversions work. Next step, we read the second one. This is where things get wonky then, right? It's the second time through. What is the I now? Yeah, the I is weird. None of that is correct. So how did we get to that spot? In. So what does in look like? What if I subtract 1? Yeah, none of that really makes any sense. Yeah, this is not the right version number. I'm not sure why the version number here is a 1. That's not the version 1. That should be version 4. So why did I get a version 1 in there? I do not know. Page header. Let's stop this and go from the beginning. Version 1 and count. Yeah, that's just not right. Okay, I'm gonna just say that the file got saved incorrectly at some point, and that's okay because I'm just going to change it now. There we go. What did it do? Yeah, that's the one. seems like maybe the tags aren't lining up correctly. So I probably just need to scrap. I'm probably just gonna call it on this style system soon and scrap it, but for now, you may all tell me what you think of this new version of the 4coder theme. Definitely some messed up stuff in there. I think that somehow the file got saved wrong, so I'm gonna delete that file soon, and it'll be fine. But and make a new one actually. Check that code over. But for now, I just want to work on this issue: style library import. Where does that get used? And can we replace it with a system that issues a request and then is gonna wait for that import to happen as a response when the file is ready, rather than stalling on the request point. So basically this result equals 0 is failure case, so 1 means success, 0 means failure on the import. Really? That makes sense actually. See, this is where it's tough because what would have to happen here is when we issue this request, we are say go to like a situation that's the same as this, only you're not accepting inputs anymore, you're just waiting. So yeah, I'd have to introduce a new step, and then that step would be something like CV mode import wait. And what this code does is it says look and see in the view sig view rect system thread exchange. So we'll use that exchange concept from before, and it's like exchange file ready. Up here it's exchange request file. That takes an exchange system. Here's the thing I need, which is you. And then color view mode would equal CV mode import wait. All of that is gone. This will move down. I'll leave that in there. Okay, so if exchange, and then up here it's like color view import file ID, and then color view import file ID, then free file exchange color view import file ID, and then in here we're finally ready to say this stuff, right? So does this make sense, everyone? Does it look like I'm doing something totally crazy? I don't know if this makes any sense to anybody, but if anyone understands what I've just begun attempting to do, and you think it's a bad idea, or you'd like me to explain it so you can tell me that it's a bad idea, now would be the time, because I'm about to start working on it if no one stops me. File. Exchange read file. Yep. Alright, so that means I have this file called threads. I think I'm going to rename this, maybe. So we need these functions here, right? First of all, let's see if we can pass this exchange everywhere. If you can, I'm not sure how, I mean, I'm not sure, uh, at this point, how to, think about the education system. You know, I'm not in a bad school. There's not all that much oop. I mean, there was one class where they kind of pushed it on me, but it was not forced like it is in some classes. There was always an option not to, and I haven't been taught any oop for a while. Uh, I'm not gonna go ahead and say that I love going to school. I don't, but it's not really about the normal problems with programming school. At least not 100% of it. Okay, so yeah, my real problem with school is just that it's really slow and not really focused on loving and caring what you were doing, and instead it's about caring about what you're doing, but it's about either how to make a lot of money or you know, less interesting things like that. How to get into grad school. These are like the things they care about. Um, so what can you do? Hmm. Interesting. All right. I was curious for a minute there about why I was needing to pass exchange to free view, but it makes sense now. Okay. Alright, so now we're passing that all over the place, which is always fun to deal with. Note to self, you definitely want to have a code transform most of the time for passing things around, but probably what you actually want is, like in that case, all of the things I passed exchange to also had a system pointer, so what I really wanted was a struct that contains a system pointer and an exchange pointer. You could probably throw a mem options pointer in there, and then you'd be really set. Like, you've just got a struct where you've got pointers to useful subsystems, and that gets passed wherever one of those is needed. Then you'd be in a really good spot. Now, these functions here are the next interesting part. Threads. Gonna change the name of that soon, but let me get these in there first. Alright, so the first one, it returns an ID. Hello, purposely drifting, welcome to the stream. Alright, that returns an ID. Exchange. And file name. Okay. Exchange file ready. That returns a B32. Let's see, that's data pointer. That up there is a thread exchange. And that right there is a file ID. And then we'll just say return result. And finally, freeing a file. Thread exchange. I32 file ID. Okay, great. Okay, let's see. I think I'm gonna call the stream here. I mean, these are all great things I can work on, and it'll be good, but I'm getting a little bit, streamed fatigue. Sorry, I know Purposely Drifting, you just showed up, but, I think that's about as much as I can pull off on a stream today. So thanks, everybody, for coming. It's been a pretty good day, and, I'll see you around. Well, wait, hold on. Wait a minute. let me investigate something. I don't think I can do much more streaming. I'm kind of getting tired here. But handmade dev. All right, good.